Welcome to the USIA podcast. I'm Ian Bott. Sir Martin Rees is the Astronomer Royal of the United Kingdom and one of the world's leading minds in cosmology, astrophysics, and the existential crises that face us here on Earth. He is a former president of the Royal Society and master of Trinity College, Cambridge. He is the author of numerous books, including his latest book, On the Future, Prospects for Humanity, as well as one of the co-founders of the Center for Existential Risk at Cambridge University. Sir Martin Rees, thank you for joining the podcast.
It's a pleasure to be with you.
So there's a lot that we can discuss about the future, but first, what motivated you to write a book about the future?
Well, of course, as you said, my professional expertise is in cosmology and astronomy, but I have, from student days been engaged with policy and politics, student demonstrations, against nuclear weapons, against the Vietnam War and all that when I was young, etc. And I got involved in the Pugwash Conference movement, which was a sort of a anti-war movement which tried to link together scientists across the divide of the Cold War, Russians and Americans and Europeans. And I got quite engaged with that. And that led to a broader interest in my later years in policy issues. And when, as you said, I became president of the Royal Society, which is like the National Academy of Sciences in the US, it was obviously part of my job to be engaged with science policy. And so my career has gradually diversified to the extent that I felt I could at least write a short book on the subject.
And you note that the Earth has existed for 45 million centuries, but this century is special. Why is that the case?
Well, it's the first time when one species, namely the human species, is having enough impact on the planet to change its future. Because there are more of us than in any previous century, and we're empowered by technology. And for the first time, we are changing the climate. We are causing mass extinctions, etc. And this is the first time that there has been such an event in human history. So it is a special time. And the other thing astronomers know is that the timeline ahead is even longer. It'll be about 50 or 60 million centuries before the sun flares up and dies. And so I therefore feel that we ought to worry a lot about the very long-term future. We are not the culmination, and we have a legacy we ought to care about.
Yes, there are plenty of things that we can worry about. What are some of the extreme risks that we are facing in the 21st century?
Well, I think that two categories are the ones that are caused by our heavy footprint collectively. And one of them, of course, is climate change, which is on course to become serious by the end of the century if we don't reduce our use of fossil fuels. And there are extinctions which have been caused by encroaching on natural land masses and forests, etc. Those are collective effects. But the other concern is that because of technology, we are hugely empowered to the extent that even a few people in principle would have the power to create something which was a global catastrophe, an engineered pandemic, a cyber attack that locked down the electric grid in the United States. All these things were not conceivable until recently, and they now are. And the world is so interconnected that a catastrophe in one continent will spread globally. So we are more vulnerable and less resilient than we were to a new class of catastrophes caused by individuals, as well as the ones we're causing collectively.
One of the points that you made in your book that I thought was very important is that when it comes to these existential risks, we tend to apply a discount rate to the future, and that the immediate trumps the long term, the parochial trumps the global. How might we circumvent this, and how might we tackle some of these big collective action issues that we're facing?
Yes, well, of course, what you say is certainly true, especially of politicians who worry about their constituents in the next election, etc. But it's more generic. And of course, in the case of the really extreme threats we're concerned about, COVID-19 is perhaps getting near that level. These are events where once is too often, and it's hard to make people care too much about something which has never happened yet. They can't assess the likelihood. And so that therefore means that we're underprepared, as we were for COVID-19, for catastrophes that may happen in the future. But as you say, we do tend to discount the future fairly heavily. In some contexts, of course, it's appropriate. I mean, if you're putting up an office building commercially, then you want to get your money back within 30 years, and so you discount future benefits at a 5% rate or something like that. But of course, when we're thinking about the fate of human beings and the loss of biodiversity, which could be irreversible, we shouldn't think like that. We should care about the welfare of children born today who will still be alive in the 22nd century. And indeed, in climate policy, where, of course, as you know, the effect will only become catastrophic in the second half of the century, but we've got to do something now, then unless you apply a lower than standard discount rate, then you will underprepare. And in fact, the campaigner Born Lomborg, who wrote a book called The Skeptical Environmentalist in Denmark, he has a group of top economists, and he's someone who downplays the risk of climate, says we should give it lower priority than helping the world's poor in other ways. But that's because he applies the standard discount rate and doesn't really care about what happens after about 2050. And I think the point is that we've got to apply a different discount rate when we're thinking about the long-term future of the planet. And if you ask how we're going to do this, I think people have to realize that it will affect their grandchildren because they do care about what happens in their lifetime. And I think religions can help. I mentioned in my book that in 2015, the Pope produced an encyclical, Laudato Si, on climate and environment, which was based on very good science. And that had a quite big effect in easing the path to consensus in the December 2015 Paris Climate Conference, because the Pope got a standing ovation at the UN. He's got 1 billion followers in Latin America, Africa, and East Asia. And politicians, knowing that the voters support a certain course of action, will take action. So if the public cares, then politicians will. And so the key thing, if you want to get these issues higher on the agenda, is to get through to the broad public. Scientists can do their bit, but charismatic figures can help a lot more. Let me give you one example. Apart from the Pope, there's been a concern in the last 2 or 3 years about plastic pollution in the ocean, a different kind of pollution. And in the UK, one of our not very enlightened ministers proposed legislation against producing non-reusable plastic drinking straws and things like that. He only did this because we'd had in the UK BBC programs called Blue Planet 2, fronted by David Attenborough, who's a sort of secular pope. And he was showing albatrosses returning to their nests and coughing up for their young, not the longed for nourishment, but bits of plastic, etc. And that was an iconic image, rather like the polar bear in a melting ice floe is for climate campaigners. And that made this politician realize that the public did care about pollution in the oceans. And therefore they would not stop voting for this guy because he proposed this legislation. And so we've got to get through to the public about these long-term issues and make them care, and then politicians will respond.
That makes sense. So if we are able to develop a public consensus, and then the public can apply pressure on politicians to take these long-term decisions, what kinds of policies do you think will be most effective in confronting climate change?
Yes. Well, I think it'll be hard to persuade the public to give up things that make their lives comfortable, etc. So I think in the case of climate change, there is actually a win-win scenario. And that is that the technically advanced countries should have a massive program of research and development into improved forms of clean energy. And if they can do that, then they can bring down their costs so that the public will happily transition to clean energy and not use fossil fuels. And that'll help countries like yours and mine to meet their 2050 targets. But more important, it will help countries like India to do so as well, because India now gets its fuel in many cases from smoky stoves burning wood and dung in people's homes. They need an electric grid, they need more power per capita, and they will build coal-fired power stations if that's the cheapest. But if it were possible for the Indians to leapfrog directly to clean energy, just as they leapfrogged to mobile phones and never had landlines, so that would enable them to reduce their CO2 emissions while developing their economy as well. And countries like mine, we produce about 1% of the world's CO2 emissions, but more than 1% of the world's clever ideas. So we could do more for the world if we not only cut our own emissions, but collaborate with the Indians to ensure that they can avoid producing a lot of CO2 as well. And that's a win-win situation, because it's hard to think of a more inspirational goal for young engineers than providing clean, affordable energy for the rest of the world. And so I think if nations prioritized R&D into those areas, it would be feasible to do this. And incidentally, I'd apply similar arguments to producing food more efficiently, because there'll be 9 billion people on the planet by 2050, and we need to ensure that they can be fed without encroaching on natural forests to grow the food. So I think that's an example where there is a win-win situation to use technology well-directed, so it allows countries to get clean energy as an affordable way.
Right. Cost does seem to be a major issue in moving towards clean energy, and research and development, I'm sure, play a huge role in realizing that. What forms of clean energy do you think show the most promise?
Well, of course, at the moment, the most important ones are wind and sun. And there are sort of niche ones like hydroelectricity, geothermal, etc. But it's wind and sun. And of course, the trouble is that they're intermittent, and they can only supply most of your energy if you also have efficient and cheap storage. So the R&D has to improve the efficiency and cost effectiveness of batteries, and have other ways of storage, and also a smart grid, because if you can transport energy in a loss-free way over long distances, from the sunny south of Europe to the darker north of Europe, etc., and east-west across the US, and maybe all the way along the Belt and Road from Europe to China to smooth over peak demand in different time zones. If you can do those things, then you can get by more readily with renewables. But I think the more important question is whether you want nuclear as part of the mix. Of course, there's some people who don't like nuclear for various reasons, but I personally feel that we should explore fourth generation nuclear, which could be more flexible and safer than the designs now, most of which date from the 1960s, because so few new nuclear power stations have been built, certainly in Western countries, in the last 20 years. So I would include nuclear in the mix as a way of providing the base load. And if you do that, then you don't need so many batteries.
Right. And an alternative, I've also heard proposals for geoengineering, so finding ways to extract CO2 from the environment. Do you see promise in that as a pursuit?
Well, of course, this is a sort of plan B if we fail to cut CO2 emissions, and if it's clear by 2050 that the temperature is rising at the higher end of the various projections, because of course, as you know, there's an uncertainty in the rate of temperature rise for a given amount of CO2, simply because of the cloud cover and things like that not being accurately modeled. So if it turns out that the climate change is dangerously fast, then there will be pressure for extreme measures like geoengineering to block out some sunlight, or to directly extract CO2 from the atmosphere. The blocking out of sunlight by putting aerosols in the upper atmosphere, etc., that could be done. In fact, it's frighteningly cheap. But it's dangerous because we don't understand the climate well enough to know what the effects would be of doing that. And of course, it wouldn't deal with the secondary effects of rising CO2, like ocean acidification. So that kind of geoengineering should be avoided. There's the other kind, which is to directly suck CO2 out of the atmosphere, either at the power stations where it's produced or just anywhere by pushing all the air through some machines. In both cases, this is very costly. And I think it's not going to be feasible to persuade, say, Indians or indeed any other country to pay the extra in order to do that, because people in a nation, they will pay money for adaptation, because adaptation benefits the country that spends the money and does it, whereas mitigation is just a global good. So if you pay a lot of money to sequester carbon from your power stations, it doesn't help you any more than any other country in the world. And so there's no specific incentive to do that. And that's why it's politically very hard, I think, to persuade people to spend a lot of money on that sort of policy. Although, as you say, it could be effective, but it's costly in energy and in money and very hard to sell to the public, I would say. So we've got to try hard, I think, to avoid getting to the stage where CO2 seems to be running out of control. And that can be done if we accelerate the programs to develop clean and affordable energy for the world.
Right. And perhaps one of the big obstacles to changing policies, changing behaviors, right, is that there's quite a bit of misinformation. There's quite a bit of reluctance to accept science out there. How might we cope with this in a world where we're just being thrown so much information? How do we actually help the public be informed about where the good science stands?
Well, I mean, I'm not so pessimistic about public understanding of science. I think they will understand it, but frankly, in this context, they don't need to understand it, because if public policy has led to the production of very efficient, very cheap source of clean energy, they will buy it if it's cheaper. So in this context, they don't need to actually be convinced with all the detailed arguments, although one hopes they will be.
Right. And I wanted to shift a bit. We're currently in the midst of a pandemic, and you were perhaps unfortunately very predictive about the dangers of pandemics, stating just last year that pandemics could cause far more societal breakdown now than in earlier centuries. What has our collective response to COVID-19 revealed about our capacity to deal with pandemics? And do you think that we will emerge from this better prepared to respond after COVID-19?
Yes, well, certainly, particularly back in a BBC lecture series I gave in 2010, I was concerned with pandemics and how we're underprepared and how they could lead to social breakdown if they overwhelm hospitals, etc. And of course, it's clear we were underprepared for this one. In my country, we were underprepared. We had prepared for an influenza pandemic because there had been pretty bad years with high infection rates in influenza, and we were prepared for those. But we were unprepared for the special features of a coronavirus pandemic, which are that there's no guarantee of a quick virus, and you need protective clothing and things like that. So we were very unprepared, as indeed I think you were. The countries of East Asia, which had SARS and MERS, they had prepared a bit better for this particular type of infection. But we were grossly underprepared, because if you think of the total global cost of this pandemic, it's going to be at least $20 trillion. And no one could have said it was hugely unlikely. It was an event that might happen once every 50 years, once every 30 years or something like that, given that we'd had 2 other coronavirus pandemics in Asia in the last 20 years. And so given that, if you work out the insurance premium by multiplying the impact by the probability, it would have been worth spending several $100 billion in improved preparedness. so that we could cope better. And the other issue is resilience. We want to be resilient so we can cope with the pandemic. And one example there is supply chains, because there's been a tendency on the grounds of efficiency and money saving for manufacturing companies to source the parts from anywhere in the world and have supply chains where a single link breaks and that stops production completely, and not to keep inventories. So it's more resilient if you have several different supply chains and if you keep an inventory so that you can buffer a stoppage in the flow of the goods for a period. And so this is an example where if you try to be too efficient, then you make yourself more vulnerable. And to take another more obvious example, Germany had a policy of keeping 20% of its intensive care beds empty all the time in normal conditions. So it had a slack and it was wasting those empty beds, whereas certainly our country didn't do that. And we had far fewer intensive care beds and therefore were more easily overwhelmed. So I think you've got to accept it's not a waste of money to be more resilient and prepared, because these things are not improbable. I like the quote from Nate Silver: "The unfamiliar is not the same as the improbable." And that's certainly true of pandemics. It was unfamiliar, but no one could have said that it was very improbable. The probability per year has been rising because of greater concentration of people and also more transmission between animals and humans, and will continue to rise because of the extra threat of engineered pandemics. So this is a rising threat, which is certainly not small now and is going to get larger.
Right. I hope that this has been a wake-up call of sorts, albeit one that comes with economic and personal difficulty. You're an astrophysicist, and you've spent a lot of time examining our universe and the phenomena within it. How likely do you think it is that there is intelligent life elsewhere? And do you think we have, if there is intelligent life, do we have a good chance to discover it in the century ahead?
Yes. Well, of course, I like to say that physics is an easy subject compared to biology. And to understand things that are just physical and inanimate is much easier than anything in the biological world. And the question you ask is a biological question, really. And it's hard because we don't actually know how life originated on the Earth. We understand evolution by Darwinian selection from the first simple organisms to the biosphere of which we're a part, 3.5 or 4 billion years after life started. But we don't understand yet the transition between complex chemistry and the first metabolizing, reproducing entities you call alive. This is a topic which people are working on now, but there's no agreement on how this happened. And so we can't yet say whether it was a rare fluke or was common. But having said that, this is an exciting subject now. And that's really because we have, of course, the possibility of probing the other planets of our solar system to look for evidence of some kind of simple life. But even more important, we've learned, mainly in the last decade or two, that most of the stars we see in the sky are orbited by retinues of planets, just as the sun is orbited by the Earth and the other familiar planets. And so there are, in our Milky Way galaxy, many, many millions of planets, rather like the young Earth, planets which are about the size of the Earth and going around a star like the sun at a distance such that water can survive without boiling away or freezing all the time. And so there are millions of places like the Earth in our galaxy, like the young Earth. And of course, unless it's a really rare fluke for life to originate, then one would expect that there might be some evidence for a biosphere on some of these planets. And the exciting thing is that we'll have some data in the next 10 or 20 years. We'll have this data in two ways. We will be able to use the next generation of bigger telescopes to take spectra star with a planet around it, and isolate the spectrum of the light from the planet, which is of course a million times fainter at least than the light from the star it's orbiting, and look for things like there's something called the red edge due to chlorophyll at about 7,000 angstroms. You see oxygen, etc. So you might see some evidence for a kind of biosphere in some of these planets, and that would happen within 10 or 20 years with bigger telescopes. And of course, there are, as you know, probes being planned to go not just to Mars, but to Enceladus, a moon of Saturn, and Europa, a moon of Jupiter, which are ice covered. And some people think that under that ice, there may be things swimming around. And there may be, we don't know. And it's worth a search, obviously. And it's not only exciting in its own right, but if you could find evidence for any life on Enceladus or Europa, that would immediately say that there was life in zillions of places in our galaxy, because if life had originated twice independently within our solar system, then it can't be a rare fluke. Okay. And its probability must be such that it's originated on a planet around most of the other stars. So that would tell us straight away that the galaxy will be teeming with life. And then, of course, you have to ask the question, if it starts a simple life, what's the probability of some kind of Darwinian evolution, which leads to complexity and intelligence like us? And of course, there are programs. Indeed, I chair a committee set up by Yuri Milner, who's a Russian investor in California, who's putting $100 million over 10 years into programs to accelerate the search for sort of artifacts, as it were, or evidence for artificial transmissions indicating some sort of technological life out there. I'm not holding my breath for success, because even if simple life is common, technological life might be rare. And if I go one step further and ask what should we expect to find, I don't think we will find any evidence for something, a flesh and blood civilization like ours. We might, but that's very unlikely. And the reason it's unlikely is this. I mentioned that we are the outcome of 3.5 or 4 billion years of Darwinian evolution. And we've had a technological civilization for a few millennia. Now, we don't know what's going to happen in the future, but a likely scenario is that within a few more centuries, we will have been superseded by some sort of electronic entities. This is certainly like what many AI pundits say, this is not a crazy idea. And if that happens, then those entities may be near immortal, and they could continue for 1 billion years, and they may not want to be on a planet. They don't need an atmosphere. They may prefer 0G, so they will go off. So my scenario is that if something happens, likes happen on the Earth, which leads to the origin of life and the emergence of a biosphere, then if you extrapolate in the future, then it will lead to electronic entities, which could be around for a long time. And so if you think of another Earth, unless it's exactly synchronized with ours, it'll either be lagging behind, in which case we know in terms of life, or it will have got a head start of maybe 1 billion years. And so anything we are likely to see is going to be something electronic, burping away in some way which we can't understand, probably not an intentional message. So it's worth looking for any kind of artifact, artificial message, even though it's unlikely to be sending us a message or anything like us, in my opinion.
Yes, and one of the points you made in On the Future is that even if intelligence were widespread in the cosmos, we may only be able to recognize a small fraction of it, right? So there may be things beyond our conception.
Yeah, that's right, because I think an important point is that we are not the culmination of evolution, and it's amazing that we've managed with our brains to understand so much about things that we didn't evolve to cope with. We evolved to live on the African savannah, and our brains haven't changed much since then, but we can make some sense of the quantum world and the cosmos. But there may be many things that we just can't understand at all and never will. But the time lying ahead is longer than the time that's elapsed up till now for biological evolution. And so we are not even perhaps a halfway stage in the emergence of complexity and intelligence. So be modest.
And regarding the emergence of intelligence, you mentioned artificial intelligence. As we think about the future, it seems likely that artificial intelligence will continue to play an increasing role. And there's a spectrum of opinions in terms of how we need to go about regulating or setting guidelines around responsible innovation in AI. Do you think that we're at a point now where we need to be taking those steps, or are those concerns about AI becoming beyond our control premature?
Well, I think there are two things. We certainly need to regulate its use in everyday business, like using algorithms to decide whether we need surgery, whether we should be sent to prison, or whether we lose our credit rating, things like that, because we shouldn't be content to leave these decisions to an algorithm, even if on the whole the algorithm is reliable. We are entitled to an explanation. So I think there are contexts like that where already we need regulation. But I think there's a separate question of whether the machines are going to sort of take over more and even take over completely and end up treating humans as an encumbrance or something like that. And of course, there are some people like Ray Kurzweil who think that within 25 years, they will surpass general human intelligence and we will perhaps want to download our brains into something electronic. So on that second, more speculative question, I'm on the conservative side. There are people like Ray Kurzweil who think this may happen within 20, 25 years. And there are others of whom I take Rodney Brooks, the roboticist, as an example, who have said it'll be a long time before we need worry less about human stupidity than about artificial intelligence. And I tend to be at that end of the spectrum. But of course, having said that, we do already need to regulate the use of AI in more modest context, because already AI is far better than humans at managing complex networks, electricity grids, traffic flows, etc. It could allow the Chinese to have a planned economy of a kind that Marx or Stalin could only dream of, because it has all the information from every financial transaction, can process it all and do all the things which the Russians could never do. So it could do those sorts of things. But in the more immediate context, it's already going to affect our lives in ways that could be dangerous, because even if an algorithm on the whole is reliable, you feel that if you are sent to prison, recommended for surgery, or even denied credit, you should be entitled to an explanation which you can contest. It's not enough to be told that the machine is more reliable than the human being they've replaced. You feel you want to be able to be sure, especially as there's lots of evidence that there can be sort of mysterious bugs in machines. It's well known that for face recognition, for instance, you can make a little tweak that completely confuses the AI. And so we need some regulation, I think, to ensure that human beings are still responsible for decisions, even though the machines can be an aid. And of course, they can be an aid, not just for routine work, but for things like medical diagnostics and surgery, etc. And that's great. But I think we like to have humans still in charge.
Yes, and
that does mean some sort of regulations.
Okay, and another area that I have concerns about where we might need regulations is within gene editing. We've seen new techniques through the CRISPR-Cas9 technology. What consequences might gene editing have on our future, and do you think we'll be able to effectively regulate this?
Well, I mean, this is interesting. I mean, because gene editing has been used to remove the single gene that causes Huntington's disease or something like that. But of course, people then raise the question of designer babies, when you can redesign the genome. And that's still, as I understand it, I'm not an expert in this, quite a long way away. because inequalities like intelligence and looks, etc., are affected by huge numbers of genes. So if you want to have a designer baby, then you have to understand which is the optimum combination of maybe thousands of genes which is needed. And we can only find that out through using AI on lots and lots of human genomes to find that out. And then you need to be able to synthesize a genome with those properties. And I think that's several decades away. But of course, if that happened, it would raise ethical concerns about, should we do this? Are there dangers? Would it lead to some sort of elite? Because this could not be afforded by everyone. So there are concerns. There's a separate set of concerns which are necessary, I think, because of dangers. And in particular, and I discuss in my book, we know it is possible for people to engineer viruses. It was possible nearly 10 years ago to modify the influenza virus to make it more virulent and more transmissible. And these so-called gain-of-function experiments were not funded by the American federal government for a number of years because they were thought obviously dangerous. And this can be done with other viruses. Of course, nations might not want to do this, even for biological weapons, because you can't predict the consequences, nor would a terrorist group with well-defined aims. But you can imagine some sort of fanatic who thought that there were too many human beings in the world, and said, well, let's try and get rid of some of them, and who could, using the facilities that are available in university or industrial labs, have a good stab at least at creating some sort of bug and releasing it, which could have a catastrophic effect. And obviously there'd be regulations against this, but the trouble is that enforcing these regulations effectively is not easy. It's not like the regulations against nuclear weapons, because you can't put a nuclear weapon without very large special purpose facilities. But you can produce a dangerous bioweapon through widely available dual use equipment if you've got the expertise. And my worry, and this is I think my number one worry for the next 10 and 20 years, is an engineered pandemic caused in this sort of way. And the problem for me is that even if we have laws which prevent the kind of thing that would be prerequisites for this, then you can't enforce these laws effectively globally any more than we can enforce the drug laws or the tax laws globally. Right. So whatever can be done will be done somewhere by someone, and that's a real concern. And I think what it's going to lead to is a growing tension between three things we want to preserve: privacy, security, and liberty. There's a tension. And we've got to give up one of those. I guess the Chinese will give up privacy. I don't know if Americans will so easily, but if they don't, they'll be more insecure. And so I think that's a big worry for me.
I think we're already feeling those tensions. And you mentioned concerns about elites, and with it in the book you talk about the risks of wealth inequality. And you say that unless inequality between countries is reduced, embitterment and instability will become more acute because the poor are far more aware of what they're missing. Yes. Are you optimistic about our ability to address wealth inequality in the decades ahead? And how might we go about doing so?
I think it's really necessary. I mean, both within countries. I mean, I say in my book that it's an ethical indictment that the 2,000 richest people in the world could double the income of the bottom billion, and they're not doing so. That's just one simple example. But I am concerned about this. But between nations, and especially, I think we should worry about Africa. The problem in Africa is that that's the one continent where the population is still growing fast. Most of it hasn't gone through the demographic transition, and its population is going to double between now and 2050, and could double again between 2050 and 2100 if it hasn't had the demographic transition by then, and it could thereby be trapped in poverty. And it's going to find it more difficult to get out of poverty because the way the East Asian tigers did it, by undercutting manufacturing costs, is no longer available to them, because we're now having reshoring of manufacturing using robots. So cheap labor, which was the advantage for Taiwan and Vietnam and South Korea, is no longer going to provide the same ladder for the countries of sub-Saharan Africa. That's one point. But the other point, as you mentioned, is that the one thing that most people in these countries already do have is access to information. Mobile phones are widespread, and so they know what they're missing. They know the injustice of their fate, and also travel is easier. So I think it's crucial for all the wealthier parts of the world, especially, of course, for Europe, to do all it can to give a boost to Africa's development by some sort of mega Marshall Plan, as it were. And this would be not solely for altruistic reasons, but to avoid an otherwise embittered and very turbulent world.
And education has traditionally played a central role in lifting people out of poverty. Yes. I'm curious where you think education might head in the decades ahead.
Well, I mean, of course, the COVID-19 has made us aware that a lot of education can be done remotely and maybe more efficiently that way. And I think it's true that education is one of the most sclerotic elements of our life. I mean, schools and classrooms haven't changed for centuries very much, and universities, I think, need to change and be more flexible than they are, certainly in my country, where they're mainly filled by people spending full time the years from 18 to 21 doing a specialized course. And it's far better to have part-time and lifelong education and all that. So I think there's a great need to reform and make education more flexible, to be taken a la carte, and to be better geared to what people want to know. I mean, looking back on my own education, I'm amazed that in full, even I went to a rather good school, good high school, how little I learned in all the time there, you know, and wasn't taught very much sort of basic biology or environmental science or anything like that, and all the things you need in order to live and understand the world we're in. So I think let's hope that COVID-19 and the transition to remote working and remote teaching is going to have a benign effect on education at school level and at university level.
Let's hope so. I had one last question, which is this is a big question, is this our final century? Between all the existential threats that we've discussed, how likely do you think we are to survive the next 100 years?
Well, when you say we, I don't think all human beings are going to be wiped out. I mean, there are scenarios where that could happen. I think that's unlikely. But I do think we'll have a bumpy ride in this. I think, given all the concerns we've touched on in this conversation, we'd be very lucky if we avoid them all. And we've had an example now of how a society, indeed the whole world, can be affected by some entirely unpredictable catastrophe. And of course, one could have had a pandemic with a far higher lethality rate than this one, which would have been far, far worse, of course. And then we are getting more and more vulnerable to electricity grid, the internet, and all these things. And so I do feel that we are living in a world which is not very resilient, and we will be lucky if we avoid some serious setbacks during this century. And that's a rather gloomy note, I'm afraid, but I do feel this is a challenge for governance. We've got to minimize people's motives for disaffection, etc.
Yes, there are certainly many considerations and challenges ahead. For our listeners who want to explore what the future of humanity might look like further, I recommend picking up a copy of On the Future. Even in a relatively short book, it covers a very broad range of these existential challenges that will be very relevant for us as we confront these challenges. Sir Martin Rees, thank you very much for joining the podcast today.
Thank you very much for having me on it.